Thank you very much, and good afternoon, everybody. Very nice to be here. My name is Oskar Tengö, and I'm Chief Strategic Initiatives Officer at the Systercon Group, and I work in our head office in Stockholm. I've been working with Systercon since 2002, so quite a long time, and since 2006 I've been in close collaboration with Mr. Zhang, and we have been collaborating with Moasoft and also Systercon Korea since 2016. We formed together. Many trips to Korea through the years, and we also had several delegations coming from many Korean organizations coming to our office, both in Stockholm but also in the US and Germany, and to our Opus Week conference in London recently. So we're very happy about that exchange that we have, both regarding our software but also regarding lifecycle management in general. And of course, we also appreciate the continued trust that our customers in Korea place in our software, and we are very, very happy about the opportunity to contribute to a more cost-effective or effective Korean defense. I also want to say, before I start, thank you to Kisti for hosting this seminar. I think it's a very great opportunity to meet and to have exchange about important topics, and also to thank you to my colleagues at the Moasoft and Systercon Korea for making this arrangement possible, and to all of you for coming, of course. So we go into just a very quick brief about Systercon Group. We have been in this field since 1970, and the sole focus have been then really to provide software and services within lifecycle management, and with specific focus on facilitating analytics and data-driven lifecycle management. Our software Opus Suite, it has a really comprehensive set of analytical capabilities in this area, and it's used by organizations worldwide for that. We have our head office in Stockholm, but we have here Systercon Korea, and we also have offices in US, UK, Germany, France, Singapore, and Australia, and then we have representatives in Italy, Taiwan, and Thailand. Defense is by far our biggest sector, and we have most customers in defense sector, but we also have customers in other areas like rail. We have Korail in Korea, for example, as customer, and also in telecom, aviation, wind power, mining, oil and gas. Okay, I want to start my presentation with an example to illustrate really why we want to do this type of analysis. And this is a result from a simulation where we are evaluating the probability of success for a specific mission. It's a 30-day mission, and we have two different system types, manned and unmanned, that will be used for a number of different mission types during these 30 days. 6 different mission types, including different types of reconnaissance and so forth, and some engagement and some area denial and so forth. So what we see here is actually the result from a simulation, and you can see that you have on the x-axis you have time, so you have the 30 days, and on the y-axis you have the number of systems that are in operation. So you see there are 3 different phases here. First phase, not so many systems operating. It looks like a few missions per day, maximum 4 systems at a time. Then we have a very intense period during 10 days with a lot of systems, up to 11 maximum. And then slower phase. The different colors is if the missions are successful or not. So green means that it was scheduled and successful. Red, that it was scheduled but it was not successful. And that can be because there was a failure during the mission, but also that there were not systems available to perform the mission because they were in maintenance or in a degraded state of some kind. So what you can see, of course, is that we have obviously a problem here. We are doing quite okay in the beginning, but we have quite a lot of red. So a lot of failed missions during the 10 days, especially towards the end. So this is, of course, very good to be able to realize this early on. This is really one important thing, that you are able to predict and evaluate and simulate to understand in advance what you get. And of course, that generates also a lot of questions. It's good to know this, but you want to know what to do about it. How can we improve this? What are the reasons for this? Is it because of problems with reliability or problems with the maintenance effectiveness or too few systems or what it is? So this is kind of the starting point. Then you start digging into what it is. So this is to illustrate, I think, one specific use of analytics and really the overall purpose that we want the defense systems to be able to perform the missions that we prioritize. And one reflection that I put up there is also that this graph actually shows a scenario with 90%. This is 90% availability. So if you did not look into detail like this, you would think, okay, it has 90% availability. That sounds good enough. But here you can see when you simulate it over time, this is probably not good enough. So you have to do more analysis. So that kind of is a good way to show that there is a need for different type of approaches in different contexts and so on. So we will come back to this. My colleague Jonas will go show this also in later. So it's kind of a cliffhanger. You can see more about how to address this later. But just to give an initial feeling for this. Then we take a step back and look at the big picture instead. I think we don't need to go through this in detail. You're probably quite familiar, but what we wanted to achieve in that previous example was, of course, effectiveness. Some kind of, we wanted to perform a certain type of selection of tasks during a certain period. We wanted them to be effective. And that depends on two things. The technical performance, the capability. Are we capable? Do we have enough speed, range, firepower, protection, and all those things to be able to meet the need? And the availability performance, of course. Are we there? Are we available? Are the systems ready and deployed? And are they in good enough condition? And of course, that depends on also a number of things. The quality or the reliability of the system. And so how often it fails. Maintainability, how easy and quick it is to maintain. And the effectiveness of the support organization. That can be summarized in these three key variables. Of course, then you have the other side. How the way that you realize this, the way that you achieve performance will also have an impact on the cost side. On the acquisition price, of course, but also on the cost it takes to maintain and operate the system through the life cycle. And the interesting thing here, I think you're probably familiar with this diagram, but the interesting thing to reflect about is how interconnected these two sides are. That it's always trade-off, and you cannot look at only one side. You also always have to consider them together. When you make decisions about investment in reliability or maintainability and so on, It's both on how it affects the system effectiveness and how it affects the different costs, and not only the acquisition cost, but they should really have the life cycle approach. So this is kind of the high level overview of what the challenge is. Of course, there's a lot of impacts of this. You can have a lot of ideas of what you wish to do with your system, but you always have to balance that off with what you have as a budget. And that's kind of one of the backgrounds why it needs to be analytical approach and data-driven approach. Because if we don't keep an eye on this, it's very easy to end up with issues with performance or issues with costs later on in the system. Oh, in the life cycle, sorry. So therefore, it has to be a continuous effort. The analytical approach should be applied right from the start, already when in the conceptual phase, when you make conceptual decisions and high-level requirements of the system, and you make your first estimates of your life cycle cost, for example. In the early phases, there you have a huge impact on the cost of the rest of the life cycle. For example, in requirement setting, that if you have a system and in the early phases you want to set some high level requirements on availability maybe and reliability and so on, it's important to get that right. And for example, if you want to set it that you wonder what is enough, so maybe you have 85 or 90 or 95%, maybe it feels easiest and safest to set as high as possible. But as some of you probably know, that it can be very sensitive where you aim for, because just a small increase in requirements can mean a very big increase in cost. So a 10% increase can sometimes mean a triple increase in the budget for operation and maintenance. So it's already there. It's very good to start doing some rough analysis using the data we have. And then, of course, continue through the life cycle to have this continuous focus on both cost and effectiveness, and all these different decision points and different analytical efforts or RAMS efforts that are done through the life cycle. There should be that simultaneous focus on how the decisions impact the cost and effectiveness in the big picture. Okay, so I think so far it's quite easy to agree that the benefits of the cost effectiveness and how it should be considered in all phases of the life cycle. But how do we ensure that we get cost-effective decisions, and what makes it so complex? Well, one thing that is very complex scenarios, of course. We have systems that are very advanced, and they contain normally hundreds or thousands of parts that have their own reliability and pricing and maintainability and so on. So you have to understand that. All those variables will impact your readiness and your cost. You also have your operations, the decision on how big your fleet is, how you deploy your systems to different locations, how they will be utilized and so on, and in what environment. That also affects your overall readiness and success, or cost effectiveness. And of course also the support system. So what maintenance concept will you repair? Will you discard when you have a failure? Where will you put your resources? How many facilities do you have? How many spares should you have in stock? How many technicians should you have? And so on. All that will also need to be captured. And all this will impact your result. And quite often these are interrelated as well. So you can, for example, compensate issues with reliability with more effective support system to raise the overall availability. And if you have problems with both, you can increase the number of systems if you have that possibility as well. So all the time you have to have that holistic approach. In today's security climate, there is of course a lot of focus on building up defense. So if you compare to some years ago, then it was about doing enough with less resources, a lot of focus on cutting costs, but now it's the other way around, that we're focusing on how to do more with more resources. More or less the same type of question, how are we cost effective, but a little bit of different situation. It's one thing, it's important to realize, you don't always feel that when you listen to politicians, that the bigger budgets does not necessarily or automatically result in bigger effectiveness. And I think that's a big task for us together as a LCM or RAMC community, to ensure that this period of now building up a stronger defense really leads to increasing the capability and readiness in the right areas. Both in the short term, because now it's a lot of focus on quick improvement, but also that we do not make bad decisions just because there's an urgency to also consider the long-term effects. The thing is that we can also, in the defense sector, we do not want to do trial and error. We are preparing for scenarios that we hope will never occur. So to be able to shape and evaluate and optimize and understand how our solutions will actually be able to handle different scenarios, of course, strategic and tactical modeling analytics is a very good way to do that. So that's quickly about kind of the background, or what we mean when we say analytical LCM. There is actually, if you want to get a little bit more information, there is a webinar that we ran recently, just a few weeks ago, but it's still available as a recorded webinar. So if you want to review that, I recommend it. It's held by our colleague Patrick Alfredsson. He is one of the methodology developers, or the senior methodology developer. He has been part of many different projects for defense forces where he has been implementing this, and for suppliers as well. So he has a lot of good examples and a lot of knowledge in this area, and I think he's very good at explaining how to take on this challenge, this responsibility of achieving life cycle management or life cycle approach. If you want even more, he is also doing a 3-day course. It's called the Executive Lifecycle Management Program, where you're getting more deeper into that. It's not a software course. It's really more the theory around lifecycle management, with a lot of actual examples and so on. So he's been doing that course for many years, and a lot of people from US and Germany and France and UK and Sweden and so on have attended it, both from the defense authorities and the supplier side. So I think the webinar is free. The course is not free, but I think it's a very good investment. It's a very good foundation for how to think in this area as well. So you can, in your booklet there, you have the QR codes you can scan, and you can read more, and you can also register to get access to the webinar if you want to start with that. Okay, so we go back to this picture where we have the 3 different areas. And as I talked about before, it's when you have the opportunity to do modeling and so on of this, of course, then you have the possibility to evaluate how you're going to succeed, your ability to handle different prioritized scenarios. You can also set and understand how to what prior requirements are appropriate. It's also a powerful way to influence the technical design, understand how to design for the life cycle or design to be able to support it in an effective way, and also to, of course, to dimension the support capabilities. So those are all kind of really obvious uses. I think it's also a very good way of communicating and collaborating to look at the results. You will see more of that when my colleague Jonas demonstrate that. But it's a very good way to have an objective view on the system and the outcome and what is causing the issues and what can be improved and why do we need certain data and things like that. And the idea is not always to get the perfect answer, but to understand what direction should we go in and what is the next step, and continuously learn and adapt and improve your solution. Okay, so that's what I wanted to say as well. But that's kind of really the playing field for Opus Suite. That's what we accomplish, or what we want Opus Suite to provide to you as our users. And just to give some overview of where it is used, I think you all come from different areas and have different applications that you think of, but Opus Suite has been used for quite a long time in a lot of different programs. So it's really built to support any type of scenario, really. And these are all examples of systems where it's used either by the government or by the supplier, and I think in the majority of these, it's actually used by both sides to ensure that it's cost effective. And we have defense authorities all over the world using Opus Suite as this. In Korea, we have ADD since I think 2009 was the first license, and they have in several divisions, and then in US and Brazil and Australia and UK, France, Germany, Spain, and so forth. So most of these have actually used our tools for a very long time. And the trend now is that it's broader and broader use. I think now it's really a complete LCM platform for most of these companies, and many are now integrating into bigger solutions. So Opus Suite becomes kind of the analysis engine for a bigger LCM solution that is used to handle, for example, data from condition-based maintenance and so forth. So that's a typical development as well. On the supplier side, same thing, that we have a lot of the big primes. I think you recognize some of the names here, and of course we're happy to have LIG Next One and Hanwha and Kai listed here as well. Okay, so now we go back to how do we actually then work with Opus Suite modeling. So in the center, you can say that to be able to make analysis, we have to make some kind of virtual representation or description of what we're looking at. And here, if we say it's a helicopter, we build a model, and now it's really buzzword to talk about digital twin. So you can say it's you have that, you can establish that description early on in your life cycle, and then you continue to add more and more details as you go through the life cycle and learn more. But it's not enough to describe the system. When you want to do this, you have to include all those three areas we talked about before and have this holistic approach. And that's really the input for Opus Suite as well. You can build very detailed models of all these things. I want to make one point there, that digital twin can give the impression that it has to be exact in every detail and so on, but really it depends on what you want to analyze. And in the early phases, you normally can keep it, you don't have so much data, and it's enough to do early estimates and so on, and then you continuously add more and more complexity and more accuracy as you go on during the life cycle. So once you have that in place, you have quickly access to decision support in a lot of different areas. So having a good model and a good way of updating and learning more about your system through the life cycle is really key. And then we continue on to the analytical capabilities. So we have all these three areas as well, and we can look at cost, like the result, of course, we want to have high effectiveness at low cost. And you can say that each possible scenario, you have some kind of overall resulting performance or effectiveness, and some kind of overall total cost. You will land somewhere in this diagram, and because there are so many variables, the combinatorics is really big. So you have billions of possible outcomes, and of course you want to make sure that you end up in the upper left side of that diagram. You want to want solutions that are here, zero cost and high availability, but that's not possible. So you want to be as high as possible, and typically you have to meet some kind of requirement. That's what you're aiming for. So that's really what you are after. You want to determine the most effective way to meet the requirements, or if you are not, if you're looking at an existing situation or existing solution, maybe you're somewhere where you have invested in a lot of resources and spares and repair equipment and so on, but you're not reaching your target effectiveness. Well, then you want to know what to do about it. There are a lot of different options. You want to invest in better reliability, maybe redundancies and the reliability block diagrams, or do you want to invest in a support system improvements, faster transports, or quicker turnaround time, and so on? There are a lot of different options. And then, of course, it's very important to evaluate how do these different improvements really result in cost and effectiveness. It can also be that you have to cut down on something. Then you want to know how can I manage and what is the minimum effect it will have on my effectiveness. So that's an important use. And of course, you always try to find ways to get up to your required level of performance as effectively as possible. So if some of you have used Opus Suite and seen the demonstrations in the past, you probably know that this curve is one central point in Opus Suite where you calculate this cost effectiveness curve. But I think it's also a good way to illustrate what we're after. We're always trying to develop and improve and manage the costs and make sure that we move upwards to a higher effectiveness and ability to perform better. And the good thing is that we have one model. So once we have built a model of these three different areas, we can make different types of analysis to accomplish different things. So strategic optimization, deterministic optimization, can be very useful for long-term strategic decisions about resources that you need during the life cycle. As we saw, average availability is not always ideal when you look at short-term scenarios, so then you need tactical optimization. Then we have another type of approach. It's meta-heuristics and combined with simulation. You can also do then simulations of the type that we saw in the first diagram there to see what will be the likely outcome in short-term or long-term scenarios, and the same thing with costing to see how will my costs add up. So this is actually really how Opus Suite is built up. You can view it or perceive it like this, that you have the model in the center, and then you have those four different analysis approaches that you can select depending on what you need to accomplish. Strategic optimization, simulation, cost analysis, and tactical optimization. But as it is more and more common to integrate Opus Suite into bigger solutions. We have also put a lot of focus through the years last several years to improve that, and to be able to interface effectively with different databases. For example, LSA database or computer-based management system or ERP system. And in fact, we have revised the Opus Suite model. In 2020, we changed the whole data structure of the Opus Suite model to be much more in line with the LSA-R standards. So it was really based on the new ASD S3000L standard. So it's really intuitive and easy to use Opus Suite together with that. And we also have a new tool called Connect that is really built to make it easy to pull data into Opus Suite and transform it as needed for analytics. It supports S3000L, but it also supports older standards like 1388 and Gaia 0007. So that makes it really easy to use throughout. Yeah, regardless of what you are using at the moment, and also if you want to transition from one to another, Opus Suite can really support that, and Connect can support that. But normally you have data in a lot of different sources, and therefore it's flexible. You can do you can import from a lot of other formats as well. For example, ODBC and JSON and so on to make sure you can import data the way and the format that you have it in, and you can also do a lot of manual entry and manual modeling and so on to make sure that you build your model and manage it. On the other side, of course, it's equally important that you not only keep these results within the expert group, you have to be able to share it and explain it and illustrate it. So we have another tool called Opus Suite Insights that helps. It's more like a BI tool for visualization and making reports and results. And of course, the aim is really to have that impact. To be data-driven, we don't only need data, we need to make sure that it really impacts and affects and improves the organization and the solution. So it helps making that, and to make sure that you use and update the database and the solutions that you have. Okay, I talked about 4 different analysis approaches, but there are a lot of different application areas. Excuse me. Anything from requirement setting to evaluating performance, to dimensioning support contracts, setting the requirement levels and so on, and evaluating and optimizing for performance, optimizing resources, optimizing spares, assortment and allocation, evaluating cost, finding cost drivers, evaluate financial risk, and so on. So you will see more of that in Jonas' presentation as well, but you have a list here. Another reflection is that it's with this type of analysis, you have a very good tool for collaboration, and that's how Opus Suite is often used between the government and the supplier. So you can have a joint picture or an objective image of the effectiveness, of course, of your system, and what is important, what data is needed, and what improvements should be done, and so on. You can have discussions about how for example, the way that the systems are used affect the resources that are consumed and things like that. So it's very good to have that in a long project that runs for several years, and a lot of things are changing over time and so on. It's very productive to have that as a tool, communication and exchange of information. And here is an example of that. It's from a Swedish program, fighter jet, Gripen fighter jets, where the government used this together with the supplier, Saab, and they had this as a tool to look at different KPIs and monitor it. You see the different lines there. Those are design reviews. So each design review to do some kind of overall review of how they are doing on overall failure rate, overall mission success, and so forth. So this is an example, but depending on where you are, I think it's very good to keep this type of continuous focus. The same, of course, for costing. So they did that as a separate, and you see that they have a lot of separate meetings and updates on the costing, even between the design reviews. So that iterative approach is really what was used here as well successfully. And that aircraft is actually known for being really good to or cost effective, or you can operate and maintain it at a very low cost compared to many of the others. So it was a good result. Okay, I was asked to give some comments on this as well. I think we had some excellent presentations already explaining CBM, so I don't need to do that. And I think the people presenting were a lot more specialized in that than I am. But from our perspective, CBM is a really good way to improve input during the in-service phase. We, as a strategic and tactical analysis tool, we often focus a lot on the strategic decisions in the early phases, but more and more it's a continued focus in the in-service and support phase, or operation and support phase. And there it, of course, becomes much more important to have this continuous update of data. So that's also driving this trend to more integrated systems. And CBM+ and machine learning is, of course, key improvements there. So there are the obvious applications of that are tactical, that you can improve the tactical optimization and tactical dimensioning or planning. Obviously, when you have better predictiveness, you can improve the scheduling of resources, improve how when your spares need to be available, and your maintenance staff needs to be available, and so on. So that eventually leads to lower cost. But you also get, when you have this type of structure in place, a better understanding of your system. So you can also use it for strategic decisions about how to improve your reliability and how to improve your planning of system assignments and all those things. So it's really an excellent tool that I think they work really well together. I think without analytical capabilities, you don't get a lot of output from gathering data like that. So it's really something that should be used together. And of course, without getting better data, you don't get good analysis. So it's really something to be used together. And I think it's good to start early with the analytics, because that can also shape how you want to use CBM and how you want to use machine learning. Where should you put your focus? What data should be gathered? How would you want to use your results? So it's important that the focus is not only how to gather data, but also how to use data and what type of decisions and what you want to achieve. I think we don't. This is again just I think quite a well-known picture to illustrate the benefits of IPS and ILS, that you have a lot of decisions in the early phases that are decisive for your overall cost in the whole life cycle. That's kind of argument to start doing analysis early. I think most of you are familiar with this concept, but it's again important to not lose. It's not done once you have your systems launched and deployed. You cannot stop. You can have to keep track on costing and also performance to make sure you keep within the budget. For example, when making decisions about midlife upgrades and changes too. And every time something changes, you have to keep track on that. Should we? I don't know if we need to go through PBL or we have time. Okay. Yeah. So this is another typical area where I think it's a lot of benefits from using this analytical approach, because there are so many potential improvements or effectiveness improvements with PBL, because you really, if you put it right, you get the possibility to affect the solution ends up with the organization that has the best opportunity to do that. But there are a lot of traps as well. So it's important to really set KPIs and make them relevant and set the right level and so on. So analytics really helps with that. And we have a whole approach for looking at the requirement setting for PBL to pick the right type of measure to make it valuable and relevant and measurable, and also to set up the incentives in a good way. So it really becomes a win-win, and when it's going well, that the supplier is properly rewarded and so forth. So it's I think it can really help with that. And of course, once you have the agreement in place, it's a lot of opportunities to continue maximizing the cost effectiveness to make sure that that the supplier can improve the effectiveness and so on, and increase the margins through being more effective, and at the same time making sure that you have high satisfaction for the customer. So normally, if you have a long PBL agreement, things will not be static. Things will change. Maybe more usage or less usage than expected, or you learn about your system and so on. So it's important to have that open and transparent collaboration to ensure that it will be successful through the whole contract time. And again, I mentioned here with a constructive dialogue that it provides that platform for good unbiased assessments and so on. Okay, so here, concluding remarks. Analysis-driven lifecycle management, or RAM-C, provides really good decision support to ensure that the defense spending right now, the increased budgets actually results in increased mission capability and readiness. It is typically a centralized capability that you have a specialist team in each program maybe to provide this, but it's important that it's not only the focus of that team. This whole thought, hearts and minds, or the philosophy should be widely adopted in the program, and the understanding of impact, the way that different things impact the cost effectiveness, should be something that's both in the management and in the whole team. So Opus Suite provides a very flexible and comprehensive platform for this. Once you have a model in place, you have several analytical approaches that gives you a broad range of application areas. And that can be used for a lot of different things, not least communication and collaboration through the life cycle of the system. Okay, 감사합니다.